here to help you with Chapter 15, Lesson 9, the Pythagorean Theorem. No matter what the date, no matter what the assignment number, go ahead and title your page, get ready for some notes. Come on back when you're ready. And actually, I have a notes page if you received that in class or if you download it online, use Kami. Let's go. Now, this is called a zip line. Some of you have seen these before, where you climb up the top of a tower and you zip down a cable all the way to a safe landing space. Now let's say this tower is 100 feet tall, 175 feet from the base of the tower to Be Happy. And you got 200 feet of cable. Well, wouldn't it be nice to know if you have enough cable to reach all the way there, or if some way near the bottom you fall to your untimely demise? That, ladies and gents, is the essence of the Pythagorean theorem. When you have a right triangle, we're going to be able to use this formula, a squared plus b squared equals c squared. Let's just keep going from there and start filling in some pieces, shall we? All right, so the big part of your notes, a squared plus b squared equals c squared. And what this means, if you read the sentence below it, the sum of the square of the legs, so you square the legs, then add the sum, is equal to the square of the hypotenuse. Okay, Mr. Cowan, but if I'm using my close reading skills, I'm putting little question marks immediately. What does that mean? I know what sum means add. I know what square means. Square means multiply a number by itself. But what are legs? What are the hypotenuse? I tell you, for whatever reason, I usually head toward the hypotenuse first. The hypotenuse is labeled C, and it is the longest edge. Now, I'm going to be honest, sometimes looks can be deceiving. You look at a triangle, you might not be able to tell which one is the longest, but this method always works. The hypotenuse, to use a little disappearing ink here, is always the edge opposite of that right angle. Meanwhile, what does that leave? That leaves the legs, and the legs are perpendicular. In other words, they are the two edges that form the right angle. And you always signify a right angle by putting a little box in the corner. Meanwhile, naturally, if C is the hypotenuse, A and B are the legs. Now, if you need to, pause, fill in your notes, come on back when you're ready. To continue on, there are two main uses of the Pythagorean theorem, at least for our 7th and 8th grade pre-algebra courses. Number one, we're going to justify that a particular triangle is in fact a right triangle. So notice right here, it looks like a right angle, but looks can be deceiving, right? So if we were to substitute numbers in for A, B, and C, the appropriate numbers, we're going to see, is it true or is it false? If it's true, shabam, it is a right triangle. If it's false, it might be just a little bigger than 90. It might just be a little tiny bit smaller than 90. It might be obtuse, it might be acute, but it is certainly not a right angle. Use number two is to actually find a missing piece, a missing link. So for instance, there's a nice picture of a ladder here. And you know the ladder is 5 feet away, the base of the ladder is 5 feet away from the wall. And you know the ladder, 5 meters, and you know it goes 20 meters up. So yeah, how long is that ladder? We're going to teach you how to use the Pythagorean theorem to actually find the measurement of that missing length. So two main uses. Number one, prove it is or is not a right triangle. Number two, if you already know it's a right triangle, then you can use that theorem to solve for a missing length. All right, we're going to go ahead into some homework here. The question at the top, the directions at the top, it does say determine whether or not each triangle with the sides of the given lengths is a right triangle. And justify. We got to give some evidence. So we can't just say yes or no. I mean, we're going to guess it and get that right half the time, right? So I'm going to write down a squared plus b squared equals c squared, where c is the longest edge. And honestly, I don't care what A or B is as long as it is not the longest edge. Now, I tend to go small, medium, large. That helps me. So in this case, the smallest or the A value would be 28, B value would be 195, C value is 197. And please note that I do have a question mark here. But I'm going to go to my trusty calculator. I'm going to type in 28 squared plus 195 squared, and then I'm going to type in 197 squared. Oh, hello. So this is a true statement, ladies and gents. But true does not answer the question. The question says determine if it is a right triangle or not. So my final answer, yes, this is a right triangle. My justification, I justified it right here. We can use numbers and symbols to justify an argument. But if you wanted to write a sentence, you could say, when I squared 28 and 195 and then added those two squares, it was exactly the same as the square of 197. Okay, meanwhile, let's take a look, and I always tend to go toward the C, and let's see, there we go. So small, medium, large, if this is a right triangle, the C must be 125. The A and the B, can I just point out that addition is commutative. So as long as you square them first, I could have put 122 squared plus 30 squared, or I could put 30 squared plus 122 squared. The sum will be the same. And by the way, in this case, the sum is 15,784. 125 squared is 15,000. So wait a second, that is false. That is not equal. And therefore, our answer is no, this is not a right triangle. Now, as you continue on, I would encourage you to actually label your numbers before you substitute in and pay special attention to which number you put in for the C value. That's all I'm going to say. At this point, I would encourage you to pause, start up number 3. You could even do the entire front page. Come on back when you're ready for the remainder of our guided practice. All right, so we're going to head to the back side now. And you'll notice that in the back side, both number 7 and number 9, hey, be careful, this is number 9, okay? I'm going out of order. Both of them already are stated to be right triangles. We don't have to check. We don't have to prove anything. What we do need to do is find a missing piece. In this case, it appears to be C feet. In this case, it appears to be A centimeters. So I'm going to do number 7 first, and then we'll do number 9 together. And I want you to look as we go through, how are these similar? How are they different? Now, first step for me is to identify what the hypotenuse is going to be. Wait a second. The longest edge, the edge opposite the right angle, is unknown. So I don't know what C is. However, I do know the two legs, and those would be 27 and 36. Now I'm going to go to my calculator because I feel that this can be simplified. Why should I write 27 squared plus 36 squared when I could just actually square them and add them together? And it turns out when I square those and add them together, I'm going to get 2025. So that's my answer. Wait a second. 2025? That's nowhere near 27 and 36. In fact, I should get used to making an estimate every time before I start. So I'll try to remember that with number 9. Now, if I see 27, I see 36, and this side seems to be a little bigger, maybe it's 40. Maybe it's 45. I don't know. But the point is 2025 is nowhere near it. Aha. That does not say C equals. That says C times itself, and I don't want to know what C times itself is. Now, ladies and gents, basically what we have to figure out is what number multiplied by itself will give us 2025. To write that algebraically, how do we get rid of add? We get rid of addition with subtraction. They're inverse operations. How do we get rid of divide? With multiply. How do we get rid of a second power? With a second root. So on both sides of this equation, we're going to write the square root. And I like to write the 2. I know some people don't write that 2. And again, a square power and a square root cancel out, leaving us with C. Meanwhile, technically you could have 2 answers, but a negative does not make sense. While you could have a negative times another negative lead us to a positive 2025, it doesn't make sense for a length to be negative. Now, in this case, I happen to notice that this is exactly 45 feet. There was no need to round. Keep that in mind as we go to the next problem. So again, we knew this was a right triangle, and therefore we use the Pythagorean theorem to find the missing piece. As we go on, let's take a look at number 9. The first thing I'm going to do is identify which of these numbers is the hello. In this case, we actually know the longest edge. We know the edge opposite of that right angle. And so 15 is the hypotenuse. Meanwhile, one of the legs is what's missing. So let's go ahead before we start solving this equation. We're going to simplify. Now, before I knew I could just put 27 squared plus 36 squared and add them up. But listen, I don't know what a squared is. I do know what 10 squared is. So let's write a squared plus, well, 10 times 10 is 100. 15 times 15 is 225. Now I'm just calling that a simplified equation. I have not solved anything yet, but why write 10 squared when I could write 100? Okay, now our goal is to find a. I want to get rid of the second power. I want to get rid of that 100. That would give us an isolated variable of a by itself. What do I get rid of first? Well, I don't want that 100. That 100 has nothing to do with the a, so let's go ahead and subtract the 100 from both sides. That would leave us with a squared is equal to 125. But again, I don't want to know what a squared is. To get rid of add, we subtracted. To get rid of multiply, we would divide. To get rid of a power, we're going to take the square root. And in this case, a square root and a square power cancel out. The square root of 125 is not exact. It is approximate. But in this case, I think it asked us to run to the nearest tenths or the nearest hundredths. Nearest tenth would be 11 and 2/10. Oh, shucks, I forgot. I'm sorry, I forgot to estimate. I meant to do that. If I see this is 10, but the biggest is 15, this looks a little bit bigger than 10, so I might say 12, I might say 13. Oh, look, 11 and 2/10 is quite close to 12 or 13. So always check to make sure that your answer is reasonable. Now let's pause for a second and talk this through. Actually, you could even pause your video, but when you do that, look at these two problems. How are they similar? How are they different? Pause, come back when you're ready. Okay, how are they similar? They both use Pythagorean theorem. They both have two numbers that are known and one number that's missing, but we immediately see an important difference. In this case, it is the hypotenuse that's missing. In this case, it is the leg. The next part, both of these, we try to simplify. But I'm going to be honest, I kind of like the green. The green simplifies very well. The blue, we simplified the 10 squared, we simplified the 15 squared. Now, from there, the blue one also has to get rid of that extra 100. We did not have that for the green, but take a look at the very last step of both of these. Both of them, to get rid of a second or square power, we take the square root. Both of them have a one-dimensional unit. We're not talking square feet. We're not talking cubic centimeters. We're just talking about a length. And yet one more difference, the green problem was exact, whereas the blue problem, well, it was a crazy, ugly, irrational number, so we had to make an approximation. All right, pause, rewind if you need to, but that, ladies and gents, is the gist of it. Again, whatever the date, whatever the assignment number, go ahead into that worksheet. Continue on. If you haven't finished the first page, do the first page, on to the second. Every time you get to that second page, ask yourself, is it more like number 7 or is it more like number 9? That's what I have, folks. Take care. Do well. Let's grow.